So I think we can get started now. So first of all, do you have any questions from the last couple sessions that we've done? I don't know if y'all went back and watched the videos or how y'all been doing on y'all's progress, if y'all been practicing or what's going on. Anything that y'all want to get cleared up before I start? Okay. So today I'm gonna talk more about the corridor and about some cool things you can do with the corridor, and maybe we'll get into start cutting the cross sections today. Maybe not, but we'll see how it goes, and I'll just stay in this area here. So well, I guess before I start showing the corridor, some of the corridor functions that I was going to show y'all, I wanted to show you some vertical geometry tools that I normally use for pretty much all the projects. So if I open the profile model of this alignment, okay, it's here, and let's say, or there's a cool function that they have. It's project profile to element. So what I usually use this for is if I'm trying to see the right of way in my profile view, because sometimes it's useful to be able to see what's happening on both sides of the right of way in relative to your center line. So to do this, we'll go to project profile to element, and then this will pop up. Then I usually select geometry right of way, and then I'll just say left right of way. And then you just follow the prompt. So then select element to project. So it's going to be the left right of way onto our alignment. And this right of way element is, we made it in a previous session, and it goes all the way, it follows the alignment all the way. So that's why it can take some time, or that's why it took some time to process. But now we can see in our profile view, we can see what's happening to our left right of way in this view. And I usually like to have this so you can see, because you really, when you're in the profile view of your alignment, you really don't see everything that's happening around your corridor, because you're only seeing the existing ground at the center line. So I think this is really useful, and I think you should use this pretty much on every project. So another cool tool that I use is this right here, profile intersection point. And I usually use this for like if we have a culvert and I'm trying to see if we have enough cover relative to the PGL. So what I'll end up doing is I'll make the alignment for the culvert, and then I'll give it the flow lines of the culvert, the upstream and downstream, and then I'll find the intersection on our alignment so we can see if we have enough cover or not. So I think I'll demonstrate the workflow for that real quick. And I'll just pick an arbitrary station and just create some elevations that couldn't work, so I can just show you how this works. So we'll just say, I'll go over here. I'm just going to do here, let's do 921. So I'm going to make my culvert alignment using just a horizontal geometry line, and then pick the feature the feature definition. We'll just convert, and then I'll come here. So we said 921. I will that in, and it'll take me there. Let's just say it's at a 40 offset, and then I'll come across. I'll key in 921 again, and then let's do another 40. So now here's the plan view of our culvert, or the location in plan view. Then I'll go to the profile view of the culvert, and let's just say this is the upstream and this is the downstream of the culvert. So then I'll just give it some arbitrary flow lines for now, and let's just say that the culvert is going to be, this is the flow line, and this is the flow line. So now we have our, let's make this. So now that we have our culvert flow line, what I usually do is use another cool tool. So if this is the flow line of our culvert, then we need to give it a thickness so that we can see the top of the culvert in our profile view. So I'm going to use this profile offset transition, which is pretty much like it's like a copy of, like it makes a copy of whichever element you choose. So here we'll just say I'll have a 2-inch pipe, and I think this should be fine. I mean a 2-foot pipe. So 2-foot pipe, and then whatever thickness, you can just say 2.5, and then we have the culvert top here, and then pick your feature definition. So then I'll look at the element, I'll click through, I don't want to mirror, and then I'll make sure to set this offset active. So now when I use the profile intersection point command, let's see what happens, and we'll talk about it. So profile intersection, so locate element to show intersection. So in this case it's going to be our alignment, and then locate element which intersects. It's going to be the culvert. So see, now we can see that this is the top of our culvert. So another thing I would do to see if we have enough cover is I would do an offset of the profile for whatever your structure depth is, your pavement. So let's just say it's 2 feet, and then you just pick some kind of element template. I'll just do this one. So if we do this, so the offset went up, then you can just type in -2. So now that we did the offset on our PGL, then now we can tell if we have cover for in regards to our culverts. And so this is a tool that I use pretty much anytime I'm designing vertical geometry. And the cool thing about this intersection point, using this profile intersection point, is if we go back to the profile of the culvert, if this ever changes, let's say it gets raised, let's say it gets raised a foot, so 225. And then I don't know if you caught it, but it moves. It moves dynamically, and this point will move in this view dynamically too. So if we move it again, then we can see that this updates. And you can either you really just pick, I guess, the offset that you choose for your for either one would be the structure depth, either the structure depth only on your PGO, or you have the structure depth plus the cover that you want. And then so you either do that or you add the cover to your culvert here, your depth of cover. So let's just be aware of that. And then don't forget to take into consideration super too, or super as well, because this elevation here, the point that we're getting is actually at the center. So just be careful, because you can we're not exactly seeing at the ends of the culvert. So just give yourself some room or some extra cover if you're ever designing vertical geometry. So those are some pretty cool tools that I use pretty much every day when I'm designing. So now what I want to show you is, let's go to the template, back to the template, and let me see. So I think I'm gonna, yeah, so I'm gonna show you how to use the parametric constraint, which is, this is the label for parametric constraints. I know I've mentioned it in previous, in one of the previous sessions, I believe, but it's kind of like you won't, because I haven't really gone into what you can do with it and how to use it. So, but I think it's really nice to know. So I'll demonstrate that, and then we'll go from there. So in this case, I'll just say, so basically what a parametric constraint is you assign your constraints to a variable. So in this case, we'll just say this is going to be our right shoulder. So I can assign this a variable, and if for some reason in our project we're we're going to be, this isn't always going to be 6, then we can change, or we can add a parametric constraint, and we can say it's going to taper from 6 to 10 in this region, and then it's going to go taper back from 10 to 6 in another region. And I can show you how to do that right now. So let me hit apply, and I'm in template 2 right now, so I'll make sure that I'm in my corridor is referencing this template. And so I'll hit close. So let's just say, let me pick some stations to, well, okay, let me just actually go to the command, and then we can do it there. So here's the create parametric constraint command, and it'll bring up this dialog box. And so you'll just follow the prompt. It says locate corridor. Then we'll pick a station range. So let's do, I'll do 887. Turn this off. And then I'll just say it's going to go to, I'll just pick it here. I'll just do like 2890. And then, okay, so this will happen whenever you're doing parametric constraints. So I just added a parametric constraint to my template, but one thing I need to make sure to do is that, so this is the correct template that I'm using, right? But anytime you make a change to your templates, you need to make sure to have the most updated template in your corridor, right? So anytime you make a template in the template library, which is what we just did, and if you see here, we have the label of the right shoulder, but and we also have the buffer, right? So these are all the parametric constraints that are in the template. But if you notice, when we go back and I do add parametric constraint, I'll locate the corridor, then it only has buffer here. So what that's telling me is that this template is not synchronized with the library, which this is an older version of the template. So anytime you make a change with in your template library, then you'll click on the little cursor for the template drop, and then you'll come here, synchronize with library. So once you do that, then we'll go back to create parametric constraint. We'll click on the corridor, and then now we see that we have the right shoulder here. See, so this is a really important key, or some really important information. So then now if we choose our limits, I said we'll just do 885 and then all the way to so then we'll do right shoulder. So here's where you pick your values. So let's just say, actually I'm gonna say it's gonna transition for 100 feet from 6 to, let's just say 10. All right, this is the initial value in our template, and this is the new value. So I'm gonna do that, and then I'm gonna add a section where it's 10, and then I'm gonna add a section where it goes back. So let's see, let's click through, and let's see. Ah, nice. So you see how this kind of opened up. So let me add another section from 2. And then, so this start value needs to be what this stop value was, which is 10, and then we'll keep it 10 for this range, and then we'll click through. So you see we added this taper for the shoulder, then we'll go back. So then we'll go from 89 to 90. Start is 10 and tapers back to 6. So let's see. Let's click through. There we go. So now let's go to the cross-section view and let's see how that looks. So if we go to our section that we just modified, we can see, and we use center on current offset. So if we zoom into this side and we place a dimension on our shoulder, then we can see what happens here. So if we scroll through, then we see our shoulder widening, and if you see a green box, then this means that a parametric constraint is applied to your template, so just keep that in mind. So we see it goes to 10 and it stays in the range that we chose, and then if we click through, then it tapers back to 6, and then there's no more parametric constraint. So this is one way to manipulate your corridor without having different templates, because maybe you would say, or maybe your thought process at first would be, okay, let's make a template for 6-foot shoulder, and let's make a template for 10-foot shoulder. And in that case, I think that would be not as optimal to do it like that, because you really want to limit the amount of templates that you use for a corridor, at least when it comes to a simple typical section like this. But obviously, when you're in a bridge section, you'll start and stop your template where the bridge approaches, then you'll skip it, and then where the bridge ends, then you'll start and stop, or then you'll start your template again. So you'll pretty much have a hole in your corridor if you ever have a bridge on y'all's projects. So this is one way to do this, and I'm going to show you another way though. So, and the other way is going to be by point control, but first I'm going to turn off these parametric constraints that we just made. Actually, no, I'll keep it, and then I'll do it on this left side. So what I'm going to do here is I'm going to create a horizontal alignment that I want my shoulder to follow, and I'm going to show you how we can control our template and corridor to that line. So if I use line between points and I use my civil AccuDraw, then I'll use these same station ranges. We'll do 85, and let's see what the offset's going to be. So this is 30. It seems 30. So I'll use 30, and then at So I'm gonna make sure my feature definition, my correct feature definition is on. I'm gonna pick roadway shoulder. And now I'm gonna pick 886. And then I'm gonna pick, it goes +4, so -34. And then I'm gonna make sure the chain's on so we can have this continue. So now I'm gonna go all the way to 889 and do the same offset. It's here. And then I'm gonna go back to 890, go back to 30. Now I'm gonna exit the command, and this might be confusing because you can't really see what's happening here. So anytime this where it gets confusing to where I can't really see, or I can't really differentiate my corridor with the lines that are drawn in my file, what I do is I come to level display, and then I'll just turn off everything in the 3D file. And it'll load a little bit, and then so you see we can clearly see our tape right here. But let me just turn off this this shoulder level. Well, no, I'm gonna leave it on because they're on the same level. Okay, so but now what I'm gonna do is I'll just complex this shoulder geometry that we want our shoulder to follow. Feature definition. Come here. Our element. And this element does not need a profile. So just make sure you don't have one, and then we're going to add a point control so that our shoulder from our template will follow the shoulder from our complex geometry here. So then I'll click corridor, I'll create a point control, and here I'm going to say left shoulder, and I'm going to say this is going to be horizontal. The mode that we want to control is horizontal because I don't have a proposed vertical geometry for this shoulder alignment that I just drew. So really it's going to choose whatever slope is in the template, and it's just going to extend it to follow this horizontal alignment. So I'll click the feature definition, make sure that the point is right. So here I don't exactly know which point the shoulder is. So let me go back to the template and we can see. So I'm going to go to corridor, come to the template library. So in this case, I want to control this shoulder because we're on the left side. So it is going to be the best to have your template know which side it's on. So you would want a L underscore cut and L underscore cut 2 for this side, and the same with an R on this side, just to distinguish, so you can see exactly, or so you can know exactly the points that you want to control to when you're using point control. But in this case, I'll just use, I know that this is the point that I want to control, shoulder 1, so then I'll just come back and I'll create a point control. We'll get the corridor, and then I will choose the point, shoulder 1, and the feature definition is going to be the shoulder. And okay, so this range is really important, and I'll try to explain it right now. But basically, the range is so wherever this point is in the template, this is the starting point of your range, right? So if this is at 0, then it's going to search from, if this point is at 0 in the template, then then this point control is going to search from 0 to -100 on your, for any referenced elements to the quarter, right? But so let's say this initial position is, let's just actually see what our initial position is here. So this is 30, so our initial position is 30. So if we use a range for our point control of 100, then it's only going to search from -30 to 100. So just be aware of that. So if you have an element that you want it to be controlled, that you want to control this point, it can't be on this side of the point. It has to be on this side, in this area between your range limit and what's in the template. So just be careful about that, because it's a problem that I always came across until I figured out how it worked. So let's go and actually do this. I'll locate the corridor, and I'll give it a range. In this case, it's throughout. I'll click through. Everything looks good. Now that our point control is applied, it still hasn't, our corridor still hasn't updated, because we need to make sure to add as a corridor reference, add this element as a corridor reference. So let's use the locate station via data point, and let's go somewhere here. And then let's zoom in so we can see what happens when we use the add as a corridor reference to our shoulder that we just made here. So you see? So now we have the same kind of, or the same taper on both sides using different methodologies. So let's just confirm that this is doing what we want it to. And it is. In this section it's 10, and then it tapers back to 6. So this is really, if you know how to do this, then it's really helpful. And what's even more cool is you can update these values and the model will update. As soon as you change the values. So it's pretty nice, and you can have a lot of control in your model if you know how to use point controls and parametric constraints correctly. So what I'm going to do now is maybe I'll open it up for some questions, and then if not, then I'll just keep on going. Okay, so now I think it'd be a good time to show how you would do superelevations or apply superelevations to your alignment and your corridor. So to do that, you click on your alignment, and no, it's not here. Okay, so you're going to come to create superelevation sections. So this is really all the superelevation commands here that you'll need. But actually, I want to get into one thing before I do superelevations. So this is really important. So make sure that you know what I'm about to say. So if I come here and you see this edit template drop, be careful with this, because if I come here and I do edit template drop and I change the template, right? I make whatever changes I want to here. It will not update the template library. So let's actually demonstrate that, just so you can kind of see what I'm talking about. So I just did edit template drop, right? I clicked on the template drop, then I did edit template drop, and I'm just going to delete this side. And then I'm going to hit OK. So you see, it only has the left side now because I just deleted everything. But if I come back to the template library, then it's still here. So you just need to be aware that you can make changes to the template drops without making changes to the template library. But just be careful. Just be careful. So if I want to get it back to where it was, I'll just come here and then I'll do synchronize with library again. And then it's going to give me this pop-up. And this pop-up always comes, or you'll always see it whenever you have a template that has been edited. So then it says template was revised. Are you sure you want to discard the changes? And you just say yes. And now we have it back to what it was. So this is really important. So make sure you know the difference between editing from the template drop and editing from the template library. So in this video, I just want to show quickly how to do the superelevations correctly, because in the last video from my session 6 of the OpenRoads workshop, I made one small mistake that led to some big problems. In a curve section, the superelevation was the opposite direction, and that's not what we want to do. So I'll show you the mistake that I made, and you'll make sure not to repeat that, and then everything should be good from there. So if we go to create superelevation sections, you give it a name, give your section a name, give it a tangent, minimum tangent length. So then we'll click the alignment, and I'm only going to do this portion where there's two curves so we can demonstrate that it works. So make sure to envelope that. I'll click through, and now I have my section. So here's the spot where I messed up. So I had this normal cross slope at 2%, but it needs to be negative 2%. So make sure that this is negative, and everything should be fine when you're creating the superelevation lengths. So I'll click through, and then I will make the right side, and I'll make sure that this is also negative. and I'll click through. And then now you see that we have our some super elevation shape here. So I usually like to change this level to the level of the section to draft corridor super elevation, and then now we can apply we can calculate the super elevations for this section here. And you get this dialog box, you pick your standards file, and then you pick your maximum super elevation that you want for the certain design speed, and click how many lanes, and if the facility is undivided or divided. So these are the settings for this corridor, or for this road. Then we'll click through. And now we'll see that this is calculated. The super elevations for this segment is calculated. So then I will exit, and then I'm going to open the actually I'm going to open a new one. Another cross-section view, and then we'll see what happens when we apply our super elevations to the corridor. So I'll click on the corridor, click on the hammer, assign super elevation to corridor. I'll look at the section, then I'll reset to complete, and these are this is the correct information here, because the center line is a pivot point, and we want this point to rotate for the right side, and the same thing for the left side, and the same thing for the right side. So we'll click OK, and we will scan through our sections. And if we place a temporary dimension line, on both edge of pavements, then we can see as we scan through the cross sections that the super elevations are sloping in the correct direction. You see it holds 4.9 through the curve, and then should transition soon. Click through. You see it transitioning back to normal crown. So I think that's a good example of the mistakes that can happen when doing super elevations. So just make sure when you're creating them at first that you place the when you're assigning your lanes to have the normal cross slope -2% for both the left and right side, and always make sure to have the left edge of pavement to have the super elevation flag along with the center line and the right edge of pavement. And that concludes the video.